right, now let's get to work with questions involving Dalton's law of partial pressure. Now here on the board we have the question which states a mixture of two gases P and Q occupying volumes 300 cm3 and 100 cm3 respectively exert a total pressure of 800 millimeter mercury. What is the partial pressure of gas Q? Now when you look at this question, in this container we have two gases, and the two gases are gas P and gas Q inserted in this container, gas Q and gas P. Now we know that in this container there are two gases that do not react chemically together. In that case, if they don't react chemically together, it simply means they will exert a pressure that is based on the pressure of one gas. Now this is pressure Q, gas Q. The pressure it will exert will be of its own pressure, while pressure P will exert its own separate pressure. So by the time we combine these two pressures together, we were told that the two pressure, combining the total pressure exerted by gas Q and P, we have a total pressure of 800 millimeter mercury. 800 millimeter mercury. Now we are asked to determine the partial pressure. You know, when we talk about partial pressure, it means the pressure exerted by a gas. So we are trying to determine the partial pressure of gas Q. Now remember in our previous video where we talk about how to calculate partial pressure, that means the pressure exerted by one gas. Here is the formula. Now we are looking for the partial pressure of Q. So the partial pressure of Q will be the mole fraction of gas Q multiplied by the total pressure. So we are going to find or solve for the mole fraction of gas Q. Now what do we do in this case? Now the mole fraction of Q will be the mole. In this case we are dealing with volumes. The volume of Q, look at this. Now we have 300 and 100 cm3. So P is 300 and Q is 100. So now let's get the mole fraction of Q. It's going to be 100 over the total volumes, which is 300 plus 100. Am I communicating? I believe I'm passing a message here. We have to get the mole fraction of the volume of gas Q, and the mole fraction of volume of gas Q will be the volume of Q divided by the total volume. So here's the volume of Q, 100 cm3 divided by the total volume, the 300 of P and the 100 for Q, and then we are going to have 100 divided by 400. Now what would be my answer? Value of 0.25. So this is the mole fraction of Q. Now getting the mole fraction of Q, now the next thing, the mole fraction of Q, the next thing is to multiply it with the total pressure. So what do I do in this case now? In this case, let me wipe off the board. Now you can see now we have gotten the mole fraction of gas Q. And this is the mole fraction of gas Q, 0.25. Now we want to get the partial pressure exerted by gas Q. Now the partial pressure means the pressure exerted by gas Q alone, and that it will be the mole fraction which we have solved for multiplied by the total pressure, which is what? It's about 800 millimeter mercury. So we now go partial pressure of Q equals what? Mole fraction of Q multiplied by the total pressure. So now partial pressure of gas Q will be the mole fraction, which is 0.25 multiplied by the total pressure, which is 800, and my answer will be, let's multiply it. We are going to have 0.25 multiplied by 800, and my answer is 200 millimeter mercury. That is my answer. Can you see how we got the answer? So I expect you guys to determine the partial pressure exerted by P, because what I solved for was the partial pressure exerted by gas Q. Now using the same method, calculate the partial pressure exerted by gas P. Please do not forget to give me a thumb up and to follow. Thank you, Uncle Chemist.